Improper integrals part 2. In this part, we're going to look at integrals of the form 1 to infinity of 1 over x to the p, where p is a constant. And we will try to determine when will this integral converge, which means the integral, or the sum, is unique and finite. And when will this integral diverge, which is something that does not converge. In the last part, we saw that the integral 1 to infinity of 1 over x dx went to infinity. That is, it diverged. Notice here that p equals 1. This is a special case. That we have to look at separately. The reason why is all other powers of p, we can use the power rule when we find the antiderivative. But we can't with this one because the antiderivative is a natural log of x. Now we also saw that when we did the integral from 1 to infinity of 1 over x squared, we got a finite answer. So when the power was 2, 1 over x to the 2, we saw that the integral converges. So how can we tell when the integral will converge or diverge based on the power? That's what we're going to look at in this part. I'm going to do the general case first, and we'll see a couple examples to show that it works. But I just want to talk theoretically about it before I do some specific examples. So if I'm going to find this antiderivative, which I'm going to rewrite as x to the negative p, now, I will do the technicality like this just to remind us that we should, although it doesn't really affect the theory of it. But when we find the antiderivative using the power rule, we know that we need to add 1 to the power and divide by that new power. The most important part, the only part I really care about to determine convergence or divergence, is the numerator. So let's look at what if p is less than 1. Well, if p is less than 1, then I have x to some power where that power is positive. For example, if p equals 1/2, just to do a specific case in the midst, if p was 1/2, then we would add x to the negative 1/2 plus 1, which is 1/2. The point is, we will end up with x in the numerator. So when we plug in infinity, I will have infinity in the numerator, which means that the integral will go to infinity and will diverge. If you need to pause the video to think about this, I recommend you do so now. But what if p is greater than 1? Well, if my power is greater than 1, we will end up with x to some number, but where that power, the new power, is negative. Just like we did with p equals 2. If I do negative 2 plus 1, I get negative 1, which means we'll end up with x to some other power. I'll go back to m, where this x to the positive power is in the denominator. So when we plug in infinity, we will get 1 over infinity, which goes to 0. Which means the integral will converge. So to reiterate, when we integrate x to the negative p, we get x to the negative p plus 1 times some constant, divided by some constant. That doesn't really matter. But if p is less than 1, we will end up with x to a positive power in the numerator. So when we plug in infinity, we will get infinity, meaning the integral diverges. If the original power is greater than 1, we will end up with 1 over x to a positive power. So when we plug in infinity, we will get 1 over infinity, which goes to 0, which means that integral converges. So p less than or equal to 1, remember that 1 was a special case. We get that this integral diverges. But if p is greater than 1, then that same integral converges. If that didn't quite make sense, let's do a couple quick examples. What if we have 1 over x to the 1/2 from 1 to infinity? I'll run through the technicality kind of quickly. We get the limit as b goes to infinity of the integral from 1 to b. Now when we integrate, remember this is really x to the negative 1/2. So if I add 1 to the power, we get x to the 1/2 divided by 1/2, or times 2, from 1 to b. And if I plug in the top limit, which is quote-unquote infinity, I get infinity, minus something which doesn't really matter. So the integral diverges. But I knew that already because p was 1/2, which is less than 1. What if we are to do something like the integral from 1 to infinity of 1 over x to the 3/2? Let's rewrite this with our technicality to remind us that we should be doing this. And I'll go right ahead here and change that x to the negative 3/2. So when we find the antiderivative, we get x to the negative 1/2 divided by negative 1/2, or times negative 2, from 1 to b. I'll rewrite this one again as negative 2 over x to the 1/2. Notice that when p was 3/2, right, my original p value was 3/2. And after I took the antiderivative, I ended up with x in the denominator. So now if I plug in x quote-unquote equals infinity, I get negative 2 over infinity, which is 0, minus negative 2 over 1. I factor out the negative 2 over here, which gave me a finite number. So this integral converges. But I knew that already because p was 3/2, which was greater than 1.